Welcome to In 5 Minutes. Let us start with the mathematical analysis of angle modulation process. We will first define frequency modulation and phase modulation mathematically. We already know their definitions otherwise. For example, frequency modulation is a process in which frequency of the carrier signal will be varied in proportion to the instantaneous amplitude of the modulating signal. And similarly, in the phase modulation process, we will be varying the phase of the carrier signal in proportion to the instantaneous amplitude of the modulating signal. In both FM and PM, we will keep amplitude constant. Okay, now let us keep these two definitions that we have just described. Let us keep them in the mathematical form. So I will start with an expression of a modulated signal. So let me take an expression of a signal which is in its modulated form. So the signal becomes Vc cos omega ct plus phi of t. Now, why am I calling it modulated signal? Now, I don't know what kind of modulated signal it is right now. It is some modulated signal. We are calling it modulated signal simply because you can see that the phase of the signal is not constant. It is function of time t. The frequency right now is the carrier frequency. We don't know whether the frequency is constant or it is also varying like phase. The amplitude you can make out is not function of time, and hence amplitude is going to be constant, and hence we will quickly see that it will be either frequency modulated signal or phase modulated signal in which the amplitude will remain constant. Without taking much time, let us quickly define the time varying phase that we have used here, phi of t, the expression that we are using. I am saying that the phase directly proportional to the modulating signal m of t. I repeat, m of t here is the modulating signal. Now, if that is the case, then it simply means that the phase of the carrier signal is varying with respect to the amplitude of the modulating signal. If I remove the proportionality sign, I can simply write phi of t as some constant k into m of t. Now let me call it a constant kp. Instead of simply writing k, I will add a suffix p. Later on, we will understand the significance of kp and we will also define it properly. So my modulated signal that we have taken now becomes Vc cos omega ct plus kp times m of t. You can easily make out that phase of the carrier signal, the carrier originally may not have any phase. Let's say the carrier signal VCT originally was Vc cos omega ct. So let's say the original phase angle was 0, but now the new phase is a function of time, and not just that it is function of time, it is proportional to the amplitude of the modulating signal. So because phase is varying in proportion to the modulating signal amplitude, with amplitude of the modulated signal remaining constant, the signal that I have taken is nothing but phase modulated signal. We will be referring to this as PM. Now let us quickly try to understand whether the frequency is also kept constant like the amplitude.